Okay, we're going to do a second example of the ratio test here. So we've already done this one in the previous video, and now we're going to work on this one. So we need to calculate the limit as n goes to infinity of the absolute value of an plus 1 over an. Now looking at this series, we have our formula for an is n to the n over n factorial, and of course an plus 1 is what you get when you replace every n in that formula by an n plus 1. So that's n plus 1 to the power of n plus 1 over n plus 1 factorial. Okay, now I need to fill in those details here. So this is equal to the limit as n goes to infinity of the absolute value of an plus 1, which is n plus 1 to the n plus 1, over n plus 1 factorial, divided by an, which is n to the n, over n factorial. Now I can discard the absolute values here because these are positive numbers for n bigger than or equal to 1, and also I can invert this fraction, so I get that this is the limit as n goes to infinity of n plus 1 to the n plus 1 over n plus 1 factorial multiplied by n factorial divided by n to the n. Now I can cancel a little. I can certainly break up this n plus 1 factorial into n plus 1 times n factorial. So that's the limit as n goes to infinity of n plus 1 to the n plus 1. Remember, n plus 1 factorial is n plus 1 times n minus 1. So that's n plus 1 times n factorial multiplied by n factorial over n to the n. And as predicted, those two disappear. And now, in fact, I can also cancel one of these n plus 1s with this n plus 1. So that's the limit as n goes to infinity, n plus 1 to the n plus 1 is n plus 1 times n plus 1 to the n. And it's that over n plus 1 times 1 over n to the n. Now I'm left with the limit as n goes to infinity, that's going to cancel, of n plus 1 to the n over n to the n. Now I can write that as the limit as n goes to infinity of n plus 1 over n to the n. And of course, that's equal to the limit dividing this interior fraction by n above and below. It's the limit of 1 plus 1 over n to the n as n goes to infinity. That's the same as the limit. I can replace that n by an x, and it's the limit as x goes to infinity of 1 plus 1 over x to the x. Now you might remember that limit. We looked at it earlier in Calculus 2. We said that this is equal to e. Or, if you didn't remember it, you could figure it out using L'Hopital's rule. So the way to do that, this is an indeterminate form. This is going to 1, and the power is going to infinity. So the way to figure out what's going on is to write it in exponential form. So it's e to the x times the natural log of 1 plus 1 over x. Now, e is continuous, so the limit as x goes to infinity of e to the power of this thing is e to the power of the limit, if that limit exists. And so that's e to the limit as x goes to infinity of x times ln 1 plus 1 over x. Now note this is indeterminate, this power of e, and I'm going to look at that on its own. The x goes to infinity, and 1 plus 1 over x goes to 1, so this goes to infinity times 0, which is indeterminate. So I'm going to calculate that limit using, first I rearrange it so that I can use L'Hopital's rule. So the limit of x times the natural log, sorry, that looks like x to the power, that's x times the natural log of 1 plus 1 over x is equal to the limit as x goes to infinity is the natural log of 1 plus 1 over x all over 1 over x. Now I have one of the basic indeterminate forms on which I can use L'Hopital's rule. This is going to 0 and this is going to 0, so it's a 0 over 0. So according to L'Hopital, that is equal to the limit as x goes to infinity of the derivative of this, which is 1 over what's inside the brackets there, times the derivative of 1 plus 1 over x, which is minus 1 over x squared. And it's that over the derivative of 1 over x, which is minus 1 over x squared. And now this is minus 1 over x squared plus over 1, so when I flip that fraction, this part will cancel with this. So that is actually equal to the limit as x goes to infinity of 1 over 1 plus 1 over x, and this is going to 1, so that's 1. So our power there is going to 1. And so therefore, this limit is e to the power of 1, which is e. Now recall that this was the limit as n goes to infinity of the absolute value of an plus 1 over an, and we're talking about this series. So the determining factor is whether this is greater than 1 or less than 1. So we found that this limit is e, and that's greater than 1. So our bottom line here is that the limit of that quotient is e, which is, greater than 1, and so the series, which was the sum from 1 to infinity of n to the n over n factorial, diverges by the ratio test. So that's our conclusion right there, because our limit was greater than 1.